So Shammy, first of all, will be the last speaker of the Rock Indie stage. So Shammy is a director of data analytics practice, and he's responsible of ensuring to bring the best world-class experience for more than 1 million users on this platform. So today, the topic selected by Shammy is Conundrum of cloud testing. I mean, now with the pandemic situations and in fact, more with the digital transformation, a lot of company has started and did most of their journey over the cloud. To make it to simplify, to bring new modern architecture concepts. So Shammy, it's over to you. So I can see that your webcam is enabled. So Shammy, how are you now? Are you ready to rock on stage?
Yep. Thank you. Thank you. So I have 2 decades of experience in building applications, building platforms, maintaining it, re-architecturing it, and mostly for performance. And predominantly I had and I am working on legacy platforms. And when doing this type of stuff, especially on the healthcare world, I've come across a lot of things, especially in the last few years when the buzzword of cloud has gained prominence, right? So there have been some incredible lessons which were all centric around performance. So when this opportunity came in, I really thought like, why don't we get in front of the audience, share some of the experiences so that when you happen to travel around the same path, probably you can be well cautioned and you can take certain D routes and avoid some of the issues which me and my team landed in, right? So that was the context behind selecting this topic. I wanted to have cloud as a primary ingredient into it. Why this is so relevant for today's discussion is whenever me and my team had been involved in discussion about building a platform or restructuring it or re-engineering it, always the discussion surrounded on the functional piece of it. How can we add in more features to it, or in certain cases, the scalability aspects of it, and of late, even security got prominence. But each and every time, performance was the last, or certain times it didn't even feature in our discussion table. But trust me, though we tried rejecting this performance and trying to underplay it, whenever the application was built and performance was not there, that particular feature ended up redefining the entire architecture. So fundamentally, if there is one strong lesson which I have to convey from my 2 decades of experience is never ever ignore performance or underplay it. It is as good or certain times even more important than the functional aspects of your system. And what types of system am I talking about? I'm talking about legacy systems. And generally, I've seen the tendency, and people say that, okay, you have a legacy system, why are you living with it? You can go to cool Java or Python and start coding it and porting it. Wish it had been so easier, but actually it is not. Because I'm talking about a system which takes care about roughly, there have been systems which takes care about more than 100 million members in a year. And in terms of, I have been predominantly working on healthcare systems. So that means that roughly in any given month, I'm looking out at a claims volume of 8 to 10 million. And these applications were written at least 30, 40 years back and had been restructured and had been enhanced. So I don't think anyone in the team has a complete grasp of what each of the application is fully doing. So when you talk about such huge volumes, and when I talk about all this 100 million plus or 10 millions per month, I'm talking purely about structured data. I'm not even getting onto your IoT sensors, wearables, and the unstructured data, which I'll cover in a moment. But all this is purely relational database, which I'm talking about. And this application processes it, right? So it is not that easy for us to just wake up in a morning, think about shutting down the current systems and rewriting it or rebuilding it in somewhere else. Wish it could have been like that. So we have to make it work. We have to make it work in a way which will address our current expectations without losing the performance, or probably I will say in a positive way, by providing us the performance guarantees. And that makes it more trickier because greenfield development if you ask me honestly, it is much easier than a system where you know only some part of it and you still inherit it and you want to go ahead and plumb it and make it work. And today, as we speak, this is the conservative number which I have put in. If you take the Fortune 500 organization, more than 50% of your systems are in legacy. So this is one aspect which you can never discount. And this 50 also signifies one unfortunate statistics. In the last 2.5 years, across the board, more than 50% of the projects which we wanted to migrate into cloud, those ambitious initiatives have failed. Or if I have to put it mildly, they didn't meet the goals which they were initially set for them. And if you ask me what was the primary reason or driver behind it, performance. Because features or functionality, I believe people are becoming better at it, good at it. Security, there have been tools which they are able to procure to do a single sign-on and do a few things there. Scaling, cloud comes with it. But performance is something which you cannot outsource or which you cannot think as after the fact. It needs to be built out. And that is what we understand when we see that more than 50% of the systems, their migration to cloud or their refactoring into cloud didn't work. And all these numbers I'm not telling you in thin air. I know that all of you have your smartphones. You can Google it out and you can definitely see the number which I have projected is basically very conservative. In certain cases, it has been much more. So in the next few minutes, let me take you through a very simplified version of the challenges which you have seen. And I'm going to walk you through 3 major points which you will come across in the different formats if you are going to do something with legacy, right? And I wanted to put in a storyline so that I know it's a time where most of the people here in Indian time zone, it's sort of a dull period, right? So I just wanted to keep it little interesting. So this is what happened. 30, 40 years back, everything was good. There was a system which was built. It takes in inputs in different forms. You have claims coming into the system via your what you call your EDI transaction or an online transaction. There have been clearing houses which will collect all the claims and give you as a batch job for you to process. And most of the claims were submitted in the paper form. And believe me, 30 years back or even 20 years back, predominantly 70% and above your inputs to the system has been coming in the form of a paper submission. So that is that to cater that type of input, the systems were built, what we are living today, right? The systems were built not for the changes which has happened now, but probably during the 70s and 80s. And what happened is the system was producing some output which was expected out of it, clear, and then it also created some sort of analytics which was mostly on your green screen, or you will be getting it in the form of your emails, or I will say printed reports. There have been reams and reams of papers which will get printed once certain mainframe job ends, right? And this is one big monolithic block. That means that if you want to make change, you need to keep adding on top of it. No one knows what each functionality is doing, but you keep building, and it gets highly complex. complex to an extent which cannot be explained. Now, when this was going all well, suddenly now you get changes. People are uncomfortable. People started whining. People started demanding more. The business nature has changed. These are the three major parameters which we have seen in any of our restructuring or replatforming exercises. The business wants interactive visualization. They don't want, they are not contented with whatever reports you just created in your green screen. They wanted to see it in their mobiles. They want to drag and drop. They want to see if I make this changes, what will be my impact. Those demands were rising up. And then you had your variables, wherein all those data, right? Now, most of us have a smartwatch. That means that I can have a very fair amount of idea on your physical activity and try to correlate it with the health information which I have. Technically, we call that as a population health management. So we can determine the wellness of a community. But now this data has to come and sit into the system so that I can do a lot of churning. And then there is an inherent need of doing all these great things, but at a reduced cost. And when I say reduced cost, just to give you a perspective on what I'm talking about is every minute when the legacy or a mainframe CPU operates, right, you are paying it $25. And certain times it goes up to 30. So I will safely put it in the range of $25 to $30 of per minute. I'm not talking about per hour, and that happens today. So these are the three major things which we always get, saying that we want all this, now do whatever you want, ensure that you don't break in your current system, but make it happen. And the last few years, right, or at least couple of 15 months, me and my team, a 25-member team, were working on such an initiative, and this is what happened. So to address your very first thing, right, I'm just taking baby steps so that it becomes easier. We thought like, okay, you want to bring in some third-party software, build a very good visualization engine on top of it. You want data to be ready. The very easiest step we thought about is take some extracts, put it in your Google Cloud. Most of the time when it comes to data part of it, the contender was either AWS or in GCP, but what we have seen of late is, as far as data is concerned, GCP has a higher edge or winning edge over the other two public clouds. So what we used to do is we used to take the data, set up a nightly job, put it into your Google Cloud Storage, which I have abbreviated as GCS, and write an analytics engine on top of it as a BigQuery, and start churning out whatever visualization you require. To an extent, it's solved a problem, but we had a lot of performance issues there. To touch upon, in case if you are working on Google Cloud now, just to let you know that don't try to stream in data into the BigQuery unless otherwise it is extremely important for you. If you start loading it from your Google Cloud storage, you will not be charged. And as the data expands, and I'm talking about several petabytes, and every day you have adding 1 terabytes of data, ensure that you have a well-defined partitioning and clustering strategy in place. Else, whatever you do as the time goes on, your performance will dip, and you will immediately start hearing a lot of noise from your business, and you have to go back and you will start re-engineering it. If you have a well-defined partition strategy as well as a clustering strategy, and you don't stream the data unless it is absolutely required, your BigQuery and GCS will handle much of your data warehouse needs. So we did that. We thought like, okay, at least we were able to curtail some noise, but actually it was not, because then we figured out that this was all overnight data warehouse or analytics, which was still in a batch mode. It was not in a real time. So it's something like this. The business was requiring us to cook and give the food right away, but what we were trying to do is retain the kitchen wherever it was and bring in some food, frozen food, and try to microwave and provide it to them. Though it was helping them to begin with, but it was not what they were expecting in. So if you imagine a situation wherein you have a patient seated in front of a physician, what we really wanted is, now I have a lot of data about the patient in my system. Now I also have your wearable data. Can I correlate it and put across a predictive modeling so that it can tell me what exactly I need to recommend in a much better way and much more informed way? Without this real-time analytics, all this data is becoming a dead data, because at the end of the day, we are not utilizing it. Probably we are just creating some utilization report which no one looks into. So they were prompting us to go for more and more. So just to give you a idea about what exactly goes behind the scenes is, when the physician looks up the patient who is just seated in front of him, that information goes to the cloud, pulls up some of the relevant data. It doesn't have the entire data set with it. Then it goes and identifies itself with the legacy system. It authenticates, it authorizes, because both are different, right? Just authentication doesn't is not enough. Then it has to go to the appropriate table. It has to extract the data. Then most of the time, the structured data is so enriched. It has all the ingredients, but we really want some of the core form. So that means that you do the opposite of it. You try to break it up and try to take the information that you need, bring it back to your cloud tables, do your predictive modeling, which might include your edge computing, and then finally present it to the dashboard. And just think about it. Uh, in a normal day, right, a physician and a patient, their attention span or their face time which they have in common is roughly around 3 to 7 minutes. That is the statistics which I get it from both UK and US health website. And within the 7 minutes, not only this information has to come back, they need to the physician needs to start applying this information. If I'm going to take half of the time in just getting the information across, most probably the physician is going to close his tablet and going to start doing it in your conventional way. So that means I need to ensure this entire chain has to be re-engineered purely from a performance standpoint. So we spent a lot of time over here saying that, okay, I get into the cloud data warehouse, BigQuery, I get some data. Can I keep the session open so that I don't get a bottleneck over authorization and authentication, so that I can have multiple queries getting in and coming out in a batch window, rather than each of the query have to go ahead and do the 9 yard of process. Yep, and without making a compromise, because I'm talking about PII data, right, and PHI as well. So that means that I don't have a way to work around the HIPAA regulations. I have to work within the framework. Then you go ahead and extract it, and then you do processing, and then take the data which is relevant and come back to the cloud. See, this is where we were hitting a bottleneck, because all these places I have a workaround. But here, when you are trying to break it down and bring the relevant data, it was becoming difficult. That is when we figured out something which is quite interesting. All the way, like the last 10 or 15 years, we have been a heavy advocates of normalizing your data and keeping it wherever you are. But now we are actually telling you the opposite. You need not normalize it to a larger extent. Denormalization improves your performance. So if you have some large chunk of data, if you want to do a trade-off between your CPU time and the storage, I believe storage has become cheaper, dead cheaper. So I don't mind creating a certain views or certain more temporary tables, or appending a column to an to the existing table, and keep more and more denormalized data, so that I can improve on my performance, which is basically this portion, wherein I can go ahead and take the raw data and skip this step and come directly to the cloud. So fundamentally, we were able to do those engineering things and bring back some of the data. And by reducing the overall time from the moment the physician tries to pulse up and the recommendation comes to his dashboard by at least 60% of it. And the major component of it is denormalization. All the other steps, when we were trying to go by step and see the improvement in performance, we were able to see that yes, they contributed, but not to a larger extent. This is one of the roadblocks which we were able to see in. So then we started, the team started identifying all the potential tables which were queried and were involved in your decision-making process. And we were trying to do a lot of denormalization. Fine. We were thinking that almost we have reached a solution. That is when the cost factor came in and hit us again, saying that now what we are actually doing is we are creating a lot of tables within the legacy and we are putting a lot of denormalized data and you are trying to send in queries and access the data. That means that in a simple terms, you have increased your CPU cycles, increased your cost of transaction. Yes, you brought down the performance, you actually you improved the performance, but at a very, very high cost. So fundamentally, that means that you're back to the drawing board, you're re-looking at the problem, saying that, okay, this doesn't work. Now I can't just take a nightly extract and do it, or neither I can have a query which goes in and comes out taking a derouted path. So finally, this is what we did. We took all the data, started putting it in a data lake, and started creating data marts around it, and started feeding in whatever visualization layer you want, whatever predictive algorithms you need. And all this, since it was happening outside our legacy, I was not touching the CPU cycles. In fact, we got a bonus because most of the data edits which are happening within the legacy, when we were trying to do it in terms of your data flow pipeline and as well as your what you call cloud compose, an Apache Beam orchestration, we were able to do it in a much efficient way, economical way, and faster. So by doing all that, at least we were able to bring down 10 million lines of COBOL code. So fundamentally what happens is now 10 million lines of COBOL code will not get executed on a daily basis, which is an enormous saving. But this design also had its flips because now we are talking about migrating your data. Still, the problem is I don't know how these applications were all written, so a good chunk of business logic is still sitting within the legacy platform. So fundamentally, it means now those logic, for it to function, it has to access the data which will be sitting in my cloud. So I have to write a API which will come and hit my cloud, take the data, get into the legacy, and do all the churning, which is fine because most of those jobs are batch jobs. So I can create some files from my Google Cloud storage and put it there into your vSAM or other structure. And I can also now gain an ability to expose this file to the required vendors and third parties in a very orderly or a very secured way using your signed URL concept. So by doing all that, right, what did we achieve this through this multiple iteration? Now, if I go back to your three things, now I have brought in my interactive visualization. Now I'm able to bring in all my IoT data and operate it seamlessly. So on top of all my petabytes of structured data, I have equally created a warehouse of your wellness data. So, and I'm able to infer real-time analytics. And I did all this, when I say I mean the team, we did all this at 25 to 30% less cost of operating it in what it took a few years back. But we did undergo a lot of lessons, not because we were unable to port a feature or functionality or security or scalability. As I said, the rejector stone was the performance, and it went on in redefining and changing the entire layout. So from design 1 to design 3, it was a 180-degree shift. So that is what has happened. And I just thought like many of you might be involved in some sort of legacy modernization or interfacing with legacy. This area is still a black hole. Not a lot of work has been done, and performance is the key, because now you're talking about multiple disparate systems which needs to connect, which needs to operate along with your new data coming in. So how do we do it? Uh, that is the challenge, and I believe that it has a lot of scope which can be improved. But this is our story as of now. Wanted to open up for any questions which you may have.
So thank you for this presentation. Let's start the Q&A. So I see that there are other PAC members connected. So Andy, Andreas Grabner is connected, and Tuan Cott as well. I'm gonna enable them. Maybe if they are not available, just let me know. So I'm gonna enable Andy's webcam and up into view, and also the Tuan Cott's webcam as well. Tuan Cott, more known as Ed Sheeran, so he's doing two roles: performance engineering and also a pop rock star.
Yes.
It's great to have fun. So Shammy, first of all, thank you for your presentation. I have one question for the audience, and I had also one question that pops up in my mind when you were delivering your presentation. So let's start with the question from the audience. So the question is, when you start performance testing a cloud application, did you migrate data first for X years as a first step and then run your search queries? Did you also had tests which mimic futuristic workload growth? How did you ingest all these years of data?
I got the second part. Sorry, can you repeat me the first part?
So the first part is, when you start your performance testing on cloud, did you migrate data first for X years as the first step, and then you run your search queries?
Yes, in fact, we took a subset of data, the latest one, the last couple of years data, and we executed a search query, because you have to remember, I was not trying to migrate the features from on-prem to cloud. Rather, we were trying to build new dashboards, new visuals, which were not there in my earlier phase. So that means that I didn't have something to compare against, saying that, okay, this worked well here, but it's not working over here. I didn't have the baseline data. So to ensure that whatever time commitment we have given to the business, saying that this will be a response time, we didn't want to migrate the entire data set, but whatever was relevant. So we just did a subset of it. So to answer your first question, yes, we just took a subset of the data and migrated to cloud.
Gotcha. And you were mentioning, saying that when you are planning to ship your data over the cloud, you need to obviously you could do some clustering and partitioning and so on, the right approach to avoid discovering major performance issues in the later month or weeks or years. So what would be your recommended approach to define the right clustering and partitioning for your application? Do you have a recommended method, or any links or things that will be meaningful for the community?
Definitely. The one is, what works in your DB2 or a vSAM environment doesn't work in the same way in the BigQuery, because this is such a very, very different system, right? So when you are deciding upon your partitioning first identify something which is unique and doesn't grow probably in a linear fashion. Try to see that, so that all your rows doesn't go ahead and sit in the same segment and it does an exhaustive search. Try to have your partitioning approach in a way that the incoming records or the incoming data is at least not very, very regularly and evenly. It is not dense or it is not focused on specific segments, but it is evenly distributed across segments. So for us, what worked is we had tried to append our primary key with our timestamp, and we were trying to do it, but it didn't work because our primary key was also increasing in a linear fashion. So we just tried to do some amount of hashing there, and we ensured that, okay, if I have say 1 gigabyte of data, all of this 1 GB doesn't go ahead and cluster around 1 or 2 partitions, but it is spread across 8 or 9 of them. That worked for us, but it might be application dependent, your database schema dependent. You might need to look into it.
Okay. Thanks for this. There's another question from the audience, which is any tips for cloud performance test engineering, type of test to execute, monitoring approach over the cloud, etc.
Varies from cloud to cloud. I believe from in terms of monitoring the cloud, I have worked both on AWS and GCP predominantly. AWS comes up with your very good CloudWatch metrics, and it helps you a lot. Whereas in GCP, Stackdriver is what something we have been heavily relying upon, and we did have some of the customization and trying to aggregate some of the sync data and migrate it into a new project itself for more and more analysis, brought in some third-party tools and do it. So if you ask me, in terms of monitoring, my personal favorite is AWS, but since data is more involved in GCP, we have of late started doing customization on the data which comes from your Stackdriver.
And a question from my end, which is not related to the question of the monitoring, but you mentioned data in GCP. Have you ever did any POC or benchmark with Snowflake? Because Snowflake has tons of features for when you have large of data available in different regions and different data source. So one thing I was interested is if you have already tested it out or measure or any feedback that could be meaningful for us.
Probably a quarter down the line, if we had this session, I could have added, because as we speak, my team is working on Snowflake. We are exploring and identifying it. So not historically, but we are currently engaged in one of the models. So maybe in the next pack session, I'll be able to share that, Hendrik.
That would be great, because I think a lot of Snowflakes has obviously a lot of major advantages. It will be great to have real examples, field examples. That will be great for us, for all of us.
Definitely.
So there's another question, but before I'm looking, so we have 7 minutes left for the Q&A. So and I want to also let Tuan ask his question. So last questions, and then I will let Tuan ask a potential question that he may have. So last question is, does it mean that no need for APM tools like Dynatrace if you're using CloudWatch?
Maybe I need to explore it. I didn't check it out. Check on that. Let me use it out.
Okay. I think from my perspective, maybe I'm wrong, and I know that CloudWatch is adding more and more features, but CloudWatch will more or less bring you more the black box monitoring with metrics that you can plot. You can obviously also collect some logging, some details from the logs that your app could throw out. But I think Dynatrace will obviously bring more insights, the white box monitoring on your app that maybe CloudWatch won't be able to cover that piece. I think it's complementary from what I see, but again, that's my opinion. But maybe if I'm wrong, please let me know on the chat for sure.
No, I'm agreeing with you, Hendrik. That CloudWatch is for me, it's the bare minimum for monitoring. It's good that AWS is putting a lot of effort into expanding it, and it shows you insight. But it's black box. You're only having details about resources and some logging, but real life user end data, that's still lacking. So APM tool is a whole different game. Yeah.
Yeah. It brings you an extra dimensions on that.
Yeah, for sure.
Tutwan, do we have any questions related to Shammy's session?
Yeah, I was wondering what your experience is regarding again performance. Of course, looking at AWS or Azure, you have things like RDS. So you have the SQL as a service or database engine as a service. In relating to just a VM and installing the database or data there. Do you have any experience in the performance between those types of products?
Is your question more like what is the experience surrounding Azure?
No, not Azure. So, for instance, take AWS ADS. So you got the database as a service and relates to just a VM and installing the database there. But in terms of performance, the ones is really easy to spin up and it's pretty fast.
Basically, you're talking about using a database as an infrastructure as a service and as well as a platform as a service, a cloud, right? We have done both. We have done both. Certain cases wherein we had certain restrictions around licenses. We have gone as an infrastructure as a service. What we have seen is it depends on the type of machine which you choose and the type of purpose which is being utilized, the amount of data which you put in. I will not completely rule out saying that when you use infrastructure as a service for your database in a cloud, it's not like it is compared to your past performance dips. Depending upon your machine types and depending upon the data which you bring in, I had an instance, if I'm not wrong, 18 months back where we did for one of our small clients, we could see that it was actually scaling up. It was scaling up and it was giving us much better performance compared to the past. But if I'm going to talk about enormous database or data which is there and a lot of your monitoring which I need to configure in terms of workload, and I don't have a dedicated admin sitting and doing all the stuff, and I wanted to consume the logs which are being created, it is a fashion now for people to use PaaS. But IaaS also has its advantage depending on the parameters which you choose it. Did I answer you?
Yeah.
We can see that.
Questions?
Yeah, I can see that Andy is connected. So I would like to ask Andy if you have any questions to Shammy.
I do, but first I want to ask if you can actually hear me because I had some challenges with the audio. That's why I was also okay. Good. So I have one observation that we have learned at Dynatrace because we run our infrastructure across all the different cloud vendors, primarily AWS though. We have seen huge differences in performance of the individual, let's say, EC2 instances, depending on in which data center and which availability zone you run. And even though, right, you pick your same kind of, let's say, EC2 instance type, it looks the same from the outside, but it actually, probably underneath the hood, there's still different hardware and there's like different workloads. Have you experienced this as well? So especially if you're using cloud infrastructure for either running the tests, like your test infrastructure or your applications, did you see different performance behavior depending on where you run?
We have not come across that scenario. Probably we took that for granted, saying that whenever you have the same type of instance, it yields you the same performance. But yours is a very interesting observation. Maybe I will start keeping eye on it. Andy, thanks for bringing it out. It is a very different and unique observation.
Yeah, I think, it also makes sense because obviously these vendors, they built their different data centers with a certain set of chips and maybe with a certain set of hardware that is available at that point. And so at least that's what we have seen. And I remember especially we've blogged about this as well in Asia Pac in Australia. We had a completely different performance behavior of these EC2 machines than we have, for instance, in Frankfurt or in the US, which for us was interesting, an interesting observation. And I wonder if we need to figure out if we first need to run some benchmarks on these machines to actually know what am I actually getting, because otherwise I run the same test, and then depending on where I run it, I get different results.
Right.
So just to add to what Andy's mentioned, so I can confirm that this is true. I mean, for example, in Australia, Amazon has a zone in Sydney, and definitely the data center coming from Sydney, you cannot compare the capacity of the machine that you have there compared to what you can get in Virginia or in Ireland. So there is a clear difference between the regions and the data centers. But so it's especially on the network side and on the CPU side, we saw also a lot of differences.
Yeah, I think we also saw a huge difference in file and I/O, like in storage speed. There was a big differentiator for us, and because we are collecting a lot of data and storing a lot of data, that made an impact, obviously, on how much data we could process and store in certain regions.
Yeah, I've seen the same, especially on the I/O side. That really differs, and especially how you got multiple tiers of storage, and they all have their own speeds. And there isn't much difference between the slowest one and a couple of tiers up. As well as, well, they say it's faster, but I haven't seen it. That so yeah, it's a good observation, and hopefully there will be a metric someday that we can observe.
It's like an aptex for infrastructure.
Yeah,
but
I believe there is a one in if you go to I was working at a client which has their own data center, and there was the CPU ready time which we had available for the VMs. So we could observe that VM was getting the performance it needed, but I don't think it would be available in AWS or Azure.
Transparency.
Yeah. And on the other side, I know it's probably not easy for these vendors either, right? Because in order to provide this really same hardware across the globe in so many different data centers, it is hard. But you're right. I mean, they have to be at least transparent and say, if I pick that instance size, then it shouldn't matter where I get it. It should always be the same. And if not, then they need to tell me. Then maybe I pay less or more depending on what I get.
Maybe we can compare the prices between the different regions. Maybe that it gives us a clue about the hardware and the speed.
Yeah, even that's also an interesting point. I mean, I don't know what is influencing the prices. I'm sure different countries where these data centers run have different tax systems and maybe different prices for energy, and that obviously factors in as well, because I assume each data center needs to kind of run efficiently and kind of profitable, and so that's why they have to do the math on how much a CPU unit costs.
Yeah.
Also on the demand, right?
On the team, yeah, exactly. Yeah.
I usually go to for me it's the difference between Europe West or North. I'll go to the Nordics because it's a little bit cheaper.
Yeah.
Is it? I never.
Yeah. Usually for me it's.
Okay.
For me, sitting in India, if I'm going to spin a server in Mumbai region, it is much costlier than spinning it in North Virginia. So normally I do it. You can compare it.
Okay, interesting. That's interesting. So definitely we need to do a sort of benchmarking of performance capacity and pricing capacity as well. So there was a company that was doing the cloud weather forecasts, and that could be something added to a feature showing capacity dependent on region and the price. That could be interesting. All right, any other questions? Nope. All right. So thank you so much, Shammy, for your first PAC. So welcome to the community. Welcome on board. Thanks for taking the time to prepare this presentation and to share your expertise. That was really meaningful. Thank you so much. All right. So